Lesson A3 finally gives us the last term that is usually involved in our quadratic equations, which is this middle linear term, the bx term, when we're in standard form. So today we're going to discover and explore what that impact that has on our parabola. So just to recap, up until this point, we've really spent several days now talking about the impact of the leading coefficient, which is the a value. So a few reminders here. When a is greater than 0, or in other words positive, our graph is going to open upward. Okay, it's going to be sort of a smiley face. And when a is less than 0, or in other words negative, it's going to open downward. It's going to be more like this, the frowny face, or the downward opening parabola. The other effect that a has is a also affects the width. Okay, so that is the job of A. It determines which direction it opens and how wide or narrow the parabola is going to be. Okay, then we talked about C. And at that point, we didn't have this middle term. And we saw that C really influenced where that parabola was located, vertically speaking. Our parabolas, when we didn't have this middle term, were still centered right in the middle of our graph, with the y-axis being the same as our axis of symmetry, and that C value either translated it that many units up or that many units down. So we know that the C value worked as a vertical translator or shifted it up and down. And then today we discover the impact when we have this middle term, the bx term. When we start including this middle term here with a degree 1 on it, this is when our parabola starts to move from one side to the other. It kind of jumps off of the y-axis and starts to either move to the right or to the left. And when that happens, you're going to notice that our axis of symmetry is no longer going to be the y-axis. Therefore, our vertex is no longer going to be on the y-axis. It's still going to be on our axis of symmetry, of course, but it's not necessarily going to be centered right in the middle of our graph where the y-axis is located. And that means that C is no longer the same point as our vertex. We'll have a vertex over here, and C will remain as the y-intercept. Okay, so C will remain as the y-intercept of our parabola, which will be nice because it will always give us an easy point to plot or graph, right? Unless it's a really large or really small number, it'll make it a really easy point to use. But C, since it's a constant, is still going to be the answer or the output when these x's are zeros. So remember, when x is 0, all of this disappears, and I'm just going to be left with that constant. And that's what the y-intercept is. It's the y-coordinate when x is 0. Okay, so the y-intercept becomes that C value, but that is no longer the same as the vertex. When we start including this bx, our parabola is going to shift from side to side. The vertex will be in a different location than the y-intercept. So this is not, at this point, it's not always the vertex. Okay. Make sure that if I write it down, you write it down. So make sure you have that in your notes. Okay. So how do we, when we start to kind of move this from side to side, how do we find out these really key features like the axis of symmetry and the vertex? Well, it all comes down to this equation right here. So as long as we have our equation, our quadratic, in this standard form, and we can identify what A and B are, we can insert them into this equation, and that equation will give us two really key pieces of information. It'll give us the axis of symmetry, which also is the x-coordinate of our vertex. Remember, those should always match, and sure enough, they are the same thing here. So we're going to find out, did it move to the right, did it move to the left, and where did that axis of to by using that formula right there, and then that same value will be the x-coordinate of our vertex. Now, I'm going to tell you something about this formula. Every textbook you see is going to have that formula written like this, okay? But I have found over the years that students have a little bit more success, especially with the signs, if that negative, if we rewrite it like this. Now, you don't have to do this, and the textbook probably won't show it like this, But if I go ahead and I take that negative and I attach it to the 2, somehow it just makes the computation a little bit easier. It's the exact same formula, guys. That does not change the value in any way. There's still a negative present, but having it attached to the 2 and thinking of this as a negative 2 makes the computation, especially when these guys are negative, one or the other or both, it kind of makes us make less mistakes as far as computing with a negative. So I like to attach it to the 2. You are welcome to do that, or you could use the original. They're both the same. I just find that students make less careless errors with this version, okay, with the negative on the 2, on that constant in the denominator, okay? All right, so before we get to actually finding all this stuff and doing the actual math, we're going to introduce just a couple of more vocabulary words, but they're going to be very familiar. I've kind of thrown these out throughout our lessons over the last several days, and that's the max or min values, okay? So the y-coordinate of the vertex, so there's our vertex, either our highest or our lowest point. The y-coordinate of that vertex is either called the maximum value or it's called the minimum value. If the a value is negative, right, less than 0, and it's downward opening, then that vertex is a max. And what we call the max is the y-coordinate of our vertex. If our a value is positive and we have an upward opening parabola, then our vertex is the lowest point, and that y value is called the minimum. So again, we've talked about that, the fact that the vertex is always either the highest or the lowest point. We're just formalizing that a little bit by saying that when we're talking about that y-coordinate of the vertex is considered the max of the curve or the min of the curve, or the maximum or the minimum of that curve. So just keep that in mind. So if we summarize how that vertex is so powerful, right? Our goal, not only does it have a very important job in most word problems, but that vertex is a very information-rich point, okay? When you know the vertex, you'll always know that the x-coordinate of that vertex is always going to be the same as our axis of symmetry. And in these equations, we're going to find that with this formula, that b over the negative 2a. And then the y-coordinate is always going to tell us what the max or min, depending on which way it opens, of the curve is. Okay, so it's got some really important information embedded into it, that vertex does. All right, so let's talk about, when you're given an equation, how we use this handy-dandy formula to get all of this good information about our parabola. So go ahead and turn the page. Okay. And let's go ahead and start doing a couple of examples here. Look at number 1. So we've got f of x equals x squared minus 10x plus 2. And what they're asking us to do in the directions here is, first of all, find the axis of symmetry. And once we know that, we want to find the complete vertex. So I want to remind you that for the axis of symmetry, we're going to use this formula here. B over A. And then remember that once we know that, we can use that value to find our vertex. And don't forget, our vertex is always a complete ordered pair. It's a point. So we're going to talk here about how we find that. All right. In fact, I'm going to kind of write it out as a step-by-step guide so you have it handy in your notes. So copy the following down. When you have an equation, a quadratic equation like this with all 3 terms, this is how you're going to tackle these tasks. Okay, number 1, you're going to use that x equals b over negative 2a to find the axis of symmetry. This is not. Okay? That's the first thing that we're going to do. That's going to give us the axis of symmetry equation, this wonderful, handy little formula there. After you find the axis of symmetry, you're going to use that axis of symmetry value as the x input. Okay, so write that down. You're going to use that axis of symmetry value that we just found. So let's say we figured out, oh, x is 7. Then we'll plug 7 back in to find the corresponding y output. Okay, so we're going to use that axis of symmetry value as the x input into the quadratic equation. Okay, and solve. And solve, sorry about that, for y. So those will be your two x and y values that then create your vertex. So let's see what that means in action. Okay, the first thing we want to do is identify what a and b are, because that is what we're going to need to use for our actual work here. So for our formula. So part A wants the axis of symmetry. So to solve part A here, remember, to find that axis of symmetry, we're going to use that b over negative 2 times a. So let's identify our values here. In this particular equation, our a value is the leading coefficient in front of x squared. So in this case, I don't see anything. That means it's a 1. And our b value is always the coefficient in this middle term with degree 1. And so in this case, the b value is negative 10. Okay. So those are the two values that I'm going to use in this formula right here. Okay. So we're going to insert those into that formula. So it's going to rewrite as x equals. The b value is going to go on top. So that's my negative 10 over negative 2. over that negative 2 times 1. So there's our a value. And if we simplify that, negative 2 times 1 is still negative 2. And then negative 10 divided by negative 2 is positive 5. So the answer to the first part here is that the axis of symmetry is at x equals 5. Okay. And then the second part is finding that vertex. So now what we do to find the vertex is we take this original function and we insert this x value. Because remember, the axis of symmetry is always the same as the x coordinate of our vertex. So, in fact, I could go ahead and say here, I already know that my vertex is going to start off with a 5 as the first ordered pair. As the first coordinate of x. So now all I have to do is find out what is the corresponding y or output or y value. So I'll just take our original function, our f of x equals x squared minus 10x plus 2, and I'll insert a 5 for x and solve. So I'm just going to evaluate this. Make sure you're hugging that input in parentheses every time. It makes a difference. Okay, and then we just solve that out. And you are welcome to grab your calculator to do that, or you could do that by hand. So parentheses, we've got a 5 squared minus 10, and then we plugged in another 5 there for x, and then plus 2. So we worked that out, and we realized, oh, so when x is 5, this output was negative 23. That is the corresponding output, the y value for our vertex. So in this case, our vertex would be at 5 comma negative 23. That would be the location. Okay, so that's how we use that formula to find the axis of symmetry and the vertex of our parabola. Let's try another one. Let's try number 3 down here. Okay, same exact kind of problem. We're going to go through the same steps. Part A is all about finding that axis of symmetry first. So again, that's that b over negative 2a. So let's go ahead and identify what a and b are. A is the coefficient, the leading coefficient that is attached to that x squared. So in this case, it is negative 2. B is the coefficient on the x term, the one that does not have the power. So in this case, that is negative 8. So that is what we are going to plug in here for our b and our a. So it's going to be x equals negative 8 over negative 2 times our a value, which is another negative 2. And we know that's really just negative 8 over positive 4. And negative 8 divided by 4 is negative 2. So our axis of symmetry is at x equals negative 2. Notice I always say x equals because it's a line. This is actually the equation of a line, but it's a vertical line. So remember, vertical lines are always x equals and then the number. So there is our axis of symmetry. Then let's go ahead and find out our vertex. So just like we did before, for our vertex, we already know that the x-coordinate has to be a negative 2 because it's got to match that axis of symmetry. To find the corresponding output or y-coordinate, we just plug that negative 2 into our equation. So we're going to do y equals negative 2 parentheses, and then we're going to insert that value we just found. So I'm just copying this top equation, and then minus the 8, plug in another for x there, and then plus the 5. Okay. And again, you could do this by hand, or you could grab your calculator. It's a good exercise. Make sure you're using negative signs unless it's a subtraction, right? So the calculator does distinguish. So I want to do negative 2 as my coefficient, and then in parentheses, I'm going to insert the negative 2 x coordinate. That's squared. And then minus 8, insert a negative 2 again, and then plus the 5. And when I work all of that out, looks like our y coordinate is 13. So this all comes out to just 13. So that means that our vertex is at negative 2, comma 13. That is the location of our vertex. So maybe try 2 and or 4, and then you can check those before we move on. And then now let's go ahead and put this together with some graphing, because most of the time, not all of the time, but most of the time, our goal is to really use this so we can graph these parabolas and see what they look like. Okay, so we want to graph the function and describe the domain and range once we've graphed it. Okay, so to graph it, we're going to need those key features. We're going to need to know where is the axis of symmetry, where's a vertex, and then a few other points. Okay, so we're going to go through a very similar process. Let's first of all identify that our a value is a 3 and our b value is a 6. And let's start by finding that axis of symmetry. So to find the axis of symmetry, we're going to do that b over negative 2a. So in this case, that means we're going to do 6 over negative 2 times 3. And negative 2 times 3 is just negative 6. And and 6 divided by negative 6 is just negative 1. So my axis of symmetry is at negative 1. So let's start to kind of lay out what this is going to end up looking like. If I start graphing, let's see, I'm going to just chance it here and put my graph pretty much in the middle. So there's my axes. I already know, just based on this, that the axis of symmetry lives at that vertical line where x is negative 1. So this is my axis of symmetry over here to the side. See how it has shifted over to the side now that that b value is at play. So there is our axis of symmetry. So it looks like our curve has shifted a little bit to the left there. Okay. Let's see what else we can find. Let's find the vertex. That's another very important piece. I can't really graph a parabola without knowing where its vertex is. So we've practiced this before. For the vertex, we actually already know that the x-coordinate must be -1. And really, it's a matter of just plugging it back in to find the y-coordinates. So I'm going to do f of -1, which is our input. I'm going to put that in. So it's going to be 3 times and then -1 squared plus 6 times -1 plus 2. And when we evaluate that, if we grab our calculator, we've got 3, we insert that -1 and square it, plus 6, insert that -1, and plus 2. Oh, looks like our output is also -1. So our vertex is at -1, comma, -1. So that means that for our parabola, this is where our vertex is, right here. -1, -1. There's my point on the x-axis, on the axis of symmetry, I mean. Okay. Now I just need a couple more points and we're done, right? So the good news is, I mentioned this earlier, the y-intercept is always this c value. That's always our y-intercept, and that always, not always, it usually gives me a pretty easy point to plot. So not only do I know that this is where our vertex is, but I also know that it's going to cross the y-axis at +2. So that's going to be right here at 2. That tells me that it should be upward opening. Do you think that's consistent with this +3? Absolutely, right? A is positive, so I had expected this to open upward. 3 is a bigger number, so I probably expect a narrower graph. And so if I copy this to the other side and reflect it across that axis of symmetry, sure enough. And guys, that's really enough. You kind of have the idea now of what these parabolas look like. At least if you have those 3 points, that usually gives you a pretty good idea of what our graph looks like. There it is. So it has all of the important criteria here. It's got its vertex in the correct place. Axis of symmetry is consistent with that as well. Our y-intercept, we reflected and copied it over to the other side of the axis of symmetry, so that's our graph. So now we can just finish this off by just stating the domain and range. Here's the good news. Domain, all real numbers, right? If it's not a word problem, all real numbers. So that's easy. And then our range is the y values. Well, all of these y values are greater than, right? This is going to go on forever upward. It's everything greater than or equal to that -1, that lowest value, that min, right? That's our min right there. So we've already kind of played around with that concept of the min. That's the lowest it's going to go. It's where y is -1. So it's all of the y values greater than or equal to that -1. Okay. Try the next one and then check your answer and see how you did and see if you are comfortable graphing these on your own. Okay, so check your graph here. I'm about to create mine, but if you got your axis of symmetry to be at +2 and your vertex at 2, -9, then you are in great shape, right? So once I saw that vertex being so low, I decided to just focus down here on the bottom part. And so I would move over 2 units to the right to x equals 2. This is where our axis of symmetry is. And I'm modeling how I want y'all to graph these. So this is, I would want you to mark your axis of symmetry with a broken line like this. So there's our axis of symmetry. Our vertex would be at 2, -9. So on our axis of symmetry and down 9 units, which I believe would be down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure enough. So there's my point 2, sorry, -9. And then I can use my y-intercept as an easy point to plot. So I also know it's crossing the y-axis at -1. And then I can also do the mirror image of that to the other side. And then if you want, you could plug in like +1 if you wanted another point. That's probably pretty smart to do. So we could say, well, what does this equal when this is 1? That's a -7. Okay, so I know I have another point at right here at -7, and then I can copy that. That gives me plenty of points here for us to create our parabola. Do we expect it to be a +1 and a little narrow because of that +2? Yeah. And then, of course, domain is always all real numbers, and all of our range values are greater than or equal to that -9 because it's above that vertex. This is a min. Okay, so that's how we use that axis of symmetry, that vertex, that y-intercept, all of those key features to graph it. Let's finish off with finding max and mins. Okay, so remember, just as a clue or a reminder, when it says tell whether the function has a maximum or minimum value, that really all depends on the positive or negative a value, because it depends on whether it opens upward or downward. Okay, so if it's opening upward, then we know it's a minimum. If it's opening downward, then we know it's a it is a maximum, right? And then we want to find it. So remember, to find the max or min, it is the y value of the vertex. So to find the max or min, you're going to do, surprise, surprise, exactly what we did here as far as like finding the x value of the vertex, then plugging it in to find the y. So this very first kind of process is exactly what we're going to do here, except we're going to call it a max or a min because it's the y coordinate of the vertex is our max or our min, right? So let's do just a couple of these, and if we feel good, we'll end on that. So let's take a look at number 8. Once again, since I first need an x value, I'm going to use my b over -2a here. And just remember, this is our a, this is our b right there. So that means that b is -5 over -2 times our a, which is that -1/2. Let's go ahead and evaluate that. I'm going to leave that alone for a second, but I know that -2 times -1/2 is really just 1. Negative times a negative is a positive. 2 times a half is 1. And -5 over 1 is just -5. So I now know that the coordinate of the vertex is at -5. Now I don't really need, that's not part of my answer, but I needed to find my answer, because now what I'll do is I will take our function or our equation up here and I'll insert that input. My max or min is going to be the y coordinate when x is -5. So I'm just going to take our equation, plug that in. All the way through. It's the same equation as up here. I've just plugged in a -5 for our x's. Let's find out what that is. So if I start off with -1/2, and then I insert a -5 for x, -5, and then I insert a -5 for x, plus the 2, turns out that the y coordinate for that vertex is 14.5. Okay, that's what I really needed in this problem, was to know this value right here. So let's finish out our answer then. Did this parabola open upward or downward based on the sign on A? It's negative, right? So on a negative, that means that this opened downward, which means our vertex is a max. So we're going to say here that this function has a max value of 14.5. That is the highest value it can achieve. There it is. Okay. Let's try one more, and if we feel good, let's actually try number 12. Okay. If we feel good about that, then we'll wrap up with that. So on number 12, same thing. We're going to do A is 9, B is 6. We'll first find our x value using our handy formula. So 6 is B over -2 times 9. That's really 6 over -18, which is just -1/3. And then we'll plug that back in to really find what we need, which is our y value. So 9, insert that -1/3 for x, plus 6, insert that -1/3 for x, and then plus 4. And we're definitely going to let the calculator do this lovely thing. We're going to do 9, insert that -1/3 squared, plus 6, insert that -1/3, and then plus the 4. And oh, that came out super nice. It just ended up being 3. Thank goodness. So y is equal to 3, and this is a positive a value, so it's opening upward, which means that vertex is a min. So we would say here that the min of this function is 3. All right, we're going to stop it there, and we'll do number 14 in class together. We'll do that word problem as a class.